In the last class, we were talking specifically about series, and today we're going to look at two different types of series. The series that we look at in this course involve converging and diverging series, and there are different kinds of those that you're going to see. In particular, converging means that it's coming together, and that's really what we looked at in the last class, the type that are coming together. Now, we looked at a specific kind, and so I want to illustrate this using just a kind of a graphic way of describing this. If we are converging, that means that we're coming together. That means that we are actually, converging. And so one particular scenario is like the bouncing ball that we were talking about in class, where if I was to bounce that ball, it would do one big bounce. The next time it would go half as high, and then it would go up half as high, and half again, and half again, and half again, and half again, until it eventually kind of settled. And of course, as science says, it never really fully comes to rest, but that's in essence what we're looking at. It is approaching one number that we can see that it's going to settle at a particular spot, okay? Another way to converge is looking at when you have a number and you bounce like a swing. Like if I was to push a swing, like on a swing set, you would push forward and then you would come back, but you wouldn't go all the way back to the same spot. You might go close, but you would go back, then you'd go forward. You wouldn't go as far forward. As long as nobody touched you, you would continue to keep bouncing back and forth until you get to a particular spot. It's a resting spot, so to speak. If we were to think of the coin drums that sometimes you'll drop coins into, or that ball thing in the middle of the mall at Salmon Run Mall, that where you put the balls in a bowl of sorts with a hole in the middle, and they spin around and spin around until they finally come to that hole that's in the center. Same kind of idea. So those are two types of converging series, and in both cases, those converging series converge upon one spot, one number. And we're to determine what that number actually is. Now, on the flip side of things, let's talk about diverging. Diverging series means to spread out, or it's getting bigger, it's diverging. Going without. So what we're going to do instead, similar to what we looked at before, if we were to take that bouncing ball, and instead of it getting smaller each time, it got bigger. This more would be explained by like an avalanche. You start with that little tiny snowball that eventually grows bigger and bigger and it picks up. Or speed of a ball going down a hill where it gets faster and faster and faster and faster. And so it also would just keep getting bigger and bigger and bigger and bigger. It's diverging. The answer to this would be infinity, because it's just continuing to get larger and larger. In theory, it will never slow down, or it will never get small. Like as long as there was an infinite supply of snow, that avalanche, as that snowball is accumulating, it would just continue to get bigger and bigger and bigger and bigger as long as we were supplying the snow, I suppose. Another type of diverging series is similar to the swing that we're looking at, but instead where you start really small and you bounce one way, and then you bounce the other way, and then you go this way, and then you go this way. And you add more, and then you take away a bunch. 3 steps forward, 6 steps back. You follow the idea? So you're going to kind of keep bouncing back and forth. Now the answer to this is also diverging, and it would be considered plus or minus infinity. It's both, because it just depends on where we would stop as to whether it was positive infinity, or if it was over here, it'd be negative infinity. And so it's considered diverging because we can't nail it into one number. It's not approaching one number, it's just getting bigger and bigger, but it's oscillating back and forth. Now what does that look like mathematically? Well, let's look at the first example here. We have 1 plus 2/3 plus 4/9 plus 8/27 plus blah, 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 blah. Continuing in that same pattern. So to start with, what's happening here is we start at 1, right? We do one jump, and then the next jump is only 2/3 of that. And then the next jump, if you think about that, is 4/9, or 2/3 of that one. And then it's 8/20, which is 2/3 of that one. And it's just going to keep, so this is an example of the first one that we described with converging series. This is converging. And the pattern that we see here is that we're multiplying by 2/3 in between each term. Okay, now let's look at the next one. The next one is 1/2. Then so we start at 1/2, then it subtracts only a quarter, then it adds only an eighth, then it subtracts a 16th, and it's bouncing in the middle. This is the second example of a converging series. The pattern we see here is we're multiplying instead of just 1/2, we're multiplying by -1/2. You'll notice the signs are changing. The signs changing is a clue that it's one of those bouncing kind. We're going to add, then we're going to subtract, then we're going to add, then we're going to subtract, and it's bouncing back and forth. So this is a converging series. Now I want you to make special note of this pattern. The converging series that we see here, this one has a pattern of 2/3, this one has a pattern of -1/2. Let's look at the next one. All right, what is our pattern of this one? We're multiplying each term by 3/2. Can you follow that? And so if I was to look at this pictorially, we'd start with our jump 1. Then we're going to get 1.5, so it's a little bit bigger. Then we're going to go to 9/4, which is like 2 1/4. And then we're going to do 3 3/4. So what's happening each time? Exactly, it's getting bigger. This is an example of a diverging series. And it's getting bigger and bigger. Now let's look at our last example that we have here. We have 1 minus 2 plus, again, notice that. Adding, then subtract, then adding, then subtract. So we would jump 1, then we'd go back 2, then we'd add 4, then we'd go back 8, and we'd add 16, and so on and so forth. So this, yes, is also diverging. It's the kind that's bouncing back and forth. And so as you look at the pattern here, we're multiplying by -2. So let's see if we can figure out just as an observation here. When we're converging, what do you notice about the patterns versus the patterns that you see here with diverging? Can you observe that? Because it would be nice, rather than for us to somehow piece out what these numbers actually mean, you know, with the 1 1/2 and 2 1/4 and 3 3/4 or whatever, or 3 3/8 rather. What you're looking to do, okay, is there a way that we can just look at the pattern in between and see if there's some significance? As you're doing this observation, it will help us in determining, so that when we look at some examples like you see here, can I tell just from looking at it, without Mrs. Madison telling you whether it's diverging or converging, how can we know if it is converging or diverging just simply by the pattern? The pattern to this one here is that we're multiplying by, notice the sign changing, so it's negative, and we multiply by 2/3. So is that converging or is that diverging? Now look at the next one. We're multiplying by, in this case, again, the signs are changing again. So it's not necessarily about the signs, because we can have sign changing. If you look over here, we had the signs changing, negative to positive, negative to positive. That wasn't what made that diverging, even though, or converging, because we had that in this one as well. But this one was diverging and that one was converging. What do we notice about the patterns here? The patterns with the converging ones are doing what? To converge that pattern, and we label the pattern as R, okay? And I'm going to use absolute value of R, because if it's positive or negative, in other words, like this one with the oscillating of the signs, understand that I'm including that into this mix here. That pattern, in order for it to converge, must be less than 1. Not equal to 1. It cannot equal 1. It must be less than 1. And that's how we know it's converging. To know if it's diverging, what does that mean? To diverge, the pattern then instead would be greater than or equal to 1. Are you with me on this? So the point being, if the pattern is less than 1, we know it converges. If it's greater than or equal to 1, then we know it diverges. So now knowing that this pattern here converges, that means to me, okay, we've got a converging pattern. We can actually come up with the answer to this. And so we did that in the days before, where we were actually looking at how do you find what that series is actually approaching. So let's do that just to kind of rehash what we did yesterday. So I'd have S equals 1 minus 2/3 plus 4/9 minus 8 over 27. Again, we notice the pattern is negative 2/3. So we're going to negative 2/3 S. That's my pattern, right? And what happens when I multiply times S times s by negative 2/3, I would get negative 2/3 plus 4/9, negative 8 over 27, blah, 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 right? Now, when we subtract, remember we're subtracting, so it changes the sign. So this becomes minus a negative. And these all change signs as well, and they cancel as we'd expect. And all that's left is that first term. So here in that to the left would be 1 minus a minus, or 1 plus 2/3, which makes 5/3 s. Keep, change, and flip. The answer to this question is what it's approaching is 3/5. You jumped 1, you came back 2/3. You jumped 4/9, you went back 8/27. And it's going to settle at 3/5. That's what that's telling you. Okay, now once we recognize that something is diverging, like we see in the second example, we know it's diverging because the absolute value of that pattern is greater than or equal to 1. And so therefore we know it's diverging. You have to recognize what kind of diverging series it is. If it's just adding progressively, getting bigger and bigger and bigger, then we know what's happening to it is it's approaching infinity. When we see the alternating signs, though, when we're going 1 minus 3/2 plus 9/4 minus 27/8, it's bouncing. This is plus or minus infinity, and that would be the answer to that example.